Picture the tallest person you've ever stood next to. Maybe a cousin who played basketball. Maybe some guy at the gym who makes door frames look personally offended. Now imagine someone almost twice that size. 9 feet tall, a hand the size of a dinner plate, a stride that covers a sidewalk in 2 steps. That person actually existed. He was American. He was born in 1918, and by the time he was 8 years old, he was already taller than his own father. This is the story of why humans never became giants. Not folklore giants, not movie giants, real biological giants. And the answer involves physics, blood pressure, childbirth, and the fact that your brain has been quietly stealing resources from the rest of your body for 2 million years. Because here's the thing nobody tells you. The limit on human height isn't really about genetics deciding that's enough. It's about a much older, much stricter set of rules. Rules written by physics, not biology. And once you understand those rules, you start to realize that giants were never impossible because nature forgot to build one. They were impossible because building one breaks almost everything else in the process. Let's start with the physics, because you can't understand why giants don't exist without understanding a very simple, very brutal law. It's called the square-cube law, first described by Galileo in 1638, and it goes like this. When something grows bigger, its volume increases faster than its surface area. Double the height of a creature, and its strength, which comes from the cross-section of bone and muscle, only goes up by a factor of 4. But its weight, which comes from volume, goes up by a factor of 8. In other words, the bigger something gets, the heavier it gets relative to how strong it is. Every giant creature in history has had to solve this problem somehow, and most of them simply couldn't. Think about ants. An ant can carry many times its own body weight. Scale that same ant up to the size of a dog, keeping its proportions identical, and it would collapse under its own mass. Its legs, still built like thin little wires, would snap instantly. This is not a hypothetical. This is why you will never see a horror movie monster the size of a skyscraper that also looks like a scaled-up spider. The math doesn't allow it. The legs would need to be so thick to support the weight that the creature would look nothing like the original animal at all. So how did dinosaurs get away with it? Argentinosaurus, one of the largest land animals that ever lived, weighed around 77 tons. That is roughly 10 times heavier than the largest elephant alive today. The answer is that dinosaurs didn't just scale up, they restructured. Their bones were often filled with air sacs, similar to birds, making them lighter for their size. Their leg bones were arranged more like pillars directly under the body rather than off to the side, which changed the physics of how weight traveled downward. Whales solved it differently. They just left land entirely. Water supports weight. That's why the blue whale, at up to 150 tons, is almost certainly the largest animal to ever exist on this planet. Heavier than any dinosaur, because gravity stops being the main opponent once you're floating. Humans did none of this. We stayed on 2 legs, on land, with solid bones and no air sacs and no water to hold us up. Which means whatever height limit applies to a normal land mammal applies to us in full. Now here's where the story gets personal, because we actually know exactly what happens when a human body tries to become a giant anyway. His name was Robert Wadlow, and by the time he died at the age of 22, he stood 8 feet 11 inches tall. He wasn't born that way. He was a normal 8.5-pound baby, but a tumor on his pituitary gland caused it to pump out growth hormone constantly, a condition called gigantism, and his body simply never got the signal to stop. By age 8, he was over 6 feet tall. By his 20s, he weighed almost 500 pounds and needed leg braces to walk, because his nervous system couldn't keep up with limbs that long. He had no feeling in his own feet. He consumed 8,000 calories a day just to keep his body running, and it was, tragically, a small brace-related blister on his ankle that led to the infection that killed him. Wadlow is important to this story for one specific reason. He's proof of concept. He shows you what happens when a human body actually attempts giant-scale growth. And the answer is that almost everything downstream starts failing. The heart has to work harder to push blood all the way up to a brain that's now much further away. The skeleton, built on the same blueprint as everyone else's, just at a larger scale, starts to buckle under weight it was never structurally designed for. The joints wear down faster. Even walking becomes a genuine engineering problem. Every additional inch above the human baseline comes with a growing list of costs, and the body starts paying those costs almost immediately. This is also why practically every verified case of extreme human height in history, going back centuries, traces back to the same cause: a tumor overproducing growth hormone. It's never just a family of naturally very tall people. Nature does not appear to have a version of humans that grows to 9 feet and lives a long, healthy life. It only has a version that grows to 9 feet and pays for it in the body's other systems. But let's zoom out even further, because there's a deeper reason we never took the giant path in the first place, and it starts with something you wouldn't expect: childbirth. Humans walk upright on 2 legs, which is fantastic for endurance and terrible for the size of the birth canal. Bipedalism narrows the pelvis compared to what a 4-legged mammal has, which puts a hard ceiling on how large an infant's head can be at birth. This is sometimes called the obstetric dilemma. Human babies are already born earlier and more helpless than almost any other primate, essentially so their heads can fit through in the first place. Now imagine trying to scale the entire species up. A bigger body needs a bigger skull to house a proportionally bigger brain, and a bigger skull simply cannot pass through a human pelvis built for our current scale. Giant humans wouldn't just struggle with walking and heart strain. Giant humans might not be able to be born at all, at least not without dying or killing the mother in the process. This alone is one of the quieter, less discussed reasons evolution never pushed us toward large body size. The exit door is only so wide. And then there's the trade-off that might be the real answer to this whole question: energy. Your brain, right now, sitting in your skull, makes up about 2% of your total body weight, but it burns roughly 20% of your entire resting energy budget. That is an enormous, almost reckless amount of fuel for something so small. Chimpanzees, our closest relatives, spend about half that on their brains. So where did humans find the extra energy to run such an expensive organ? One leading explanation is that we traded for it. As early humans started eating more calorie-dense food, more meat, more cooked food, and developed shorter digestive tracts as a result, the energy that used to go toward digestion got rerouted upward. We didn't get taller, we got smarter, at the direct metabolic expense of getting bigger. Evolution, in a very real sense, had a limited construction budget, and our ancestors spent it on brain power instead of height. A species can be huge, or a species can be clever. It's very hard to fund both at once. This actually helps explain something that seems unrelated at first. Every culture in history has legends of giants. Goliath in the Bible, Jotuns in Norse mythology, giant kings in ancient Chinese and Greek texts. For a long time, these were dismissed as pure myth. But some historians now think a portion of these stories may have been inspired by real people, individuals with exactly the kind of pituitary condition Robert Wadlow had, appearing in small ancient communities where nobody had a medical explanation for why one person kept growing far beyond everyone else. A person like that, standing head and shoulders above an entire village, wouldn't need much exaggeration to become a legend. Reality only had to bend the story a little. So why did humans never become giants? Not because giants are impossible in nature. They clearly are possible, underwater, or with hollow bones, or with legs shaped like columns. Humans just never had access to any of those workarounds. We stayed 2-legged, land-bound, warm-blooded, and increasingly brain-heavy, and every one of those choices quietly closed the door on size a little further. The few humans who did grow to giant scale weren't proof that it can work. They were proof of exactly how much has to go wrong for it to happen at all. There's something oddly reassuring in that. We didn't miss out on being giants. We just spent that evolutionary budget somewhere else, on the 3 pounds of tissue currently reading these words and wondering, even for a moment, what it would be like to be twice your size.